Welcome everyone to diagnosing and locating replaceable glass fuses on a P-Series or Smart MULTI system. So Roland, we have some glass fuses here that a lot of technicians out in the field may miss. And I think it's because they're covered with a little plastic boot, right? And a little cover over the fuses. And in this case, we're working on a P-Series system. So there are 4 fuses that we're dealing with. F1 through F4. They're labeled F1, F2, F3, and F4. So looking at this unit, and we have a meter set up here, we'll take a look at tracing the path of electricity. But if we come upon a system, and this happens all the time in class, you get an indoor unit, there's no power to the indoor unit, which means there's no power to the controller on the wall. What does the student end up trying to do when they see no power to the controller on the wall? They try ripping it off the wall.
Oh yeah,
right. So I end up with damaged controllers in my training room. So don't think you got a problem with the controller right off the bat. Take a look at your voltage and backtrack and follow your voltage path. It's like a road map following any schematic. So looking at this right now, we have a plug coming into our fuse block, and there are 2 glass fuses on the left, 2 glass fuses on the right. So the 2 glass fuses on the left-hand side, if we were to follow that schematic, they lead to S1 and S2. So what does S1 and S2 feed?
that feeds our head.
Our indoor unit, right?
Unit.
So S1 and S2 on the indoor unit. If our glass fuses are compromised, if they are blown, whatever it may be, we're going to lose power to our indoor unit, right? So now we're looking at the right side of the fuse block. And we have fuses F3 and F4, replaceable glass fuses. And those are feeding our components. Anything that needs 208 single phase. So reversing valves, solenoid valves. Some units may have more than 1 solenoid valve, especially the Smart MULTI. We're looking at a couple of SV1 and SV2, maybe a base pan heater, some additional components, some accessories that need that 208 reversing valves, solenoid valves, and any accessories on the right-hand side. So how do we diagnose and follow the path of electricity through those fuses?
Well, there's a couple ways you can do that. Old school is possibly just shutting down the power, pulling the fuse out, laying it on a table, ohming it out to see if you have continuity, verifying that it's closed or if it's open. I like to do it with power to the system. And what I'm going to do is check voltage drop across the fuse. So basically I'm going to read 0 potential difference between one side of the fuse and the other. Now, just to make sure, it could be 0 voltage. So it's not a bad thing to do to verify voltage to ground if in fact you're reading 0 potential difference across the fuse. If the fuse in fact was bad, you would read supply voltage across that on your voltmeter.
And that's a good point, because a lot of people don't understand that, right? And let's just take a switch, just a regular household switch. And if that switch is closed to a load, and we put our meter across that switch, what should we see on our meter?
Well, our meter should read 0, but it's not 0 volts. It's 0 potential difference. Obviously, if you take a look at the light is on. So therefore, you know that is reading voltage across that, but there's no difference from what comes in to what comes out. That's why we read 0 potential difference. Now, if the light was off, I would also go to ground to make sure I don't have any voltage to that switch.
Right. So when that switch is open,
now what happens now, that switch is open, the L2 or the neutral side is backfeeding through that light bulb. It's nothing more than a wire. L1 is going into the switch. So now I have a difference between L1 and neutral. And I would read 120 volts if that's the case.
Least path of resistance.
Absolutely.
It's going through the meter.
Parallel
right?
to the
Switch is
switch.
closed. It's bypassing the meter. You're not going to read anything. So same thing with checking the fuses in place, going across the fuse. And I always try to hammer this home to students in my class that checking certain paths of electricity from leg to ground is not always a good idea, especially with 208, L1, and L2, because we want to put our leads across L1 and L2 and follow that through the system. Going from L1 to ground or leg to ground can give us some false readings, right? We could get back-fed voltage, and now we're even more confused than when we started.
But like I said earlier, I'm comparing it to something. I'm comparing it to an initial reading on my voltmeter that is saying 0. So I am now comparing that to ground to verify if in fact voltage is coming in. So let me take a reading.
Yeah, go for it.
Okay, so I'm just picking any fuse I want. In this case, I'm picking the first one on the left. And what I'm doing is I'm on my voltage scale, and you can see that I am bouncing voltage at 0.002 of a volt. So basically, I have no difference between the right side and the left side. So to verify I have voltage there, because it could be 0 volts, I'm going to go to ground. And if you see I go to ground, I read 1 leg of voltage coming into that fuse, which is 124 volts. So once again, I go across it, and it is no longer reading 0 volts. It's reading 0 potential difference.
Gotcha. Yep. Awesome. Makes sense. So again, the fuses are kind of hard to find sometimes. On the Smart Multi, we're looking at F1 and F2. It's just a left side of the fuse block for our components because a little bit different setup. We're looking at 2 glass fuses. On the P-Series style, we're looking at 4 sets of glass fuses or 4 fuses. And they're covered by a plastic boot. So don't miss those. They're kind of a yellowish clear color. And again, if you want to take the fuse out and ohm the fuse out, check continuity across the fuse to see if it's blown, you can do that as well.
But just another thing, we can look at the back of the panel. The diagram on the back of the panel is pretty much laid out the exact way you're going to see the board here. So you can identify fuses on that diagram. The other thing, when we do take out a fuse, always remember, when we disconnect the power, we're looking for the LED lights to dim out. And at that point, the capacitors are completely drained of charge, so I cannot cause any damage to the board.
Excellent. All right, that about wraps it up on fuses. Thanks for watching the video. We'll see you on the next one.